which builds on top of assignment 8, we are going to be diving deeper into binary trees. We are going to use the tree node class that we created in assignment 8 to create a binary tree abstract data type class. And then we are going to use this class to implement some functionality of the binary tree. Specifically, what you will be implementing is the delete function. And as you can see, we will be implementing the delete function. The in-order traversal, the insert, and insert method is going to be available to you. What you will be carrying forward is the search method that you wrote for assignment 8, and you will be writing a new method called delete. The delete method is very interesting because let's say we have a tree that looks like this. Then, and then this is 4. There are 3 cases for the delete method. In order to keep the tree sorted, which is our goal, we have 3 cases to consider when we delete a node. One, the 3 cases are that the deleted node is a leaf node, let's say for example 4. In this case, the first thing we will have to do is search for the node. If 4 is found, if it is not found, then it's not there. We don't do anything. But if it's not found, if it is found, then what we need to do is we need to keep track of its predecessor or the parent of 4, so that we will have to do a few things. Number one, we of course have to finding the predecessor or the parent node, find the parent, and then determine if this node is right or left successor. This is important, right? Because if we know whether it's a right or left successor, we can set the links of this node correspondingly. We know that 4 comes from the left branch, and therefore we can set this one. The third step that we will do then is we will set the left pointer of this node to null. That effectively removes the link from the tree of this node, and then our task is going to be releasing this node memory, and then so that's step number 3. And then the fourth thing is decrement the node count by 1. So the 4 steps once again is search for the leaf node. If it is a leaf node, then we need to do the following steps. Number 1, find the parent of this node. Number 2, determine if it's on the left branch or the right branch of the parent. If it's on the left branch, set this left pointer to null. So now this tree is no longer part of this, and then delete the memory and decrement the node by count by 1. So this is what is going to be part of the first option, which is what if it's a leaf node and then there is we are deleting the leaf node. Now we may have another situation where what we want to delete is a node which is not the leaf node. So this is the second case. Has one child, right? And in this case, we have to, number 1, find the node. And then what we need to do is find the predecessor, like we did before. We need to know whether the deleted node is a right successor or a left successor, same as before. But now what we also need to do is we need to not change this right link to null, but what we are going to do is we are going to set this link to the right of 11. So now what we are going to do is remove this link, and this is going to be overwritten by the link to 11. So we are going to connect 9 directly to 11, right, over navigating around 10. And so once the pointer to 10 is not there from 9, it's pointing to 11, then these pointers are, then 10 is basically cut off from the tree. And then we will delete the memory for this, and we will decrement the count by 1. We don't need to necessarily set the right pointer of 10 because this node is going to get deleted in any case. But what we need to do is set 9 to 11 and delete this memory, decrement the count. So this also is fairly simple. It's not super complicated. The last option needs a little bit more work. The last option is what if is the option when it has 2 child nodes. And that could be, I'm just going to draw this tree one more time here. 5 goes to 4, to 7, to 6, goes to 9, and 10, and 11, and erase all of this stuff. So the node that we are trying to delete is, let's say, node number 7. Now here, if we delete the node 7, then the question is what should come here? And the answer to that is what should take the place of 7 is the in-order successor of 7. What is the in-order successor of 7? It's the number, the least number on the right path that comes after 7. In this case, the in-order successor, let me add one more node here. In this case, the in-order successor of 7 is actually 8. It's not 9 or 10 or 11, even though they are successors, but it's actually 8. And what we would like to do then is to remove 7, and in its place we would like to put 8, so that the rest of the tree is the sequence. Even though it looks like a linear sequence, you see, this is what happens. Sometimes when we remove a node, then the tree collapses to a linear sequence. But what we're trying to do here is move the in-order successor to the position of the node that's going to be deleted. So in order to delete a node which has 2 children, the first thing that we will need to do is, of course, find the parent node, because we need to set the parent node. The parent node now has to be set to the in-order successor of 7. So find the parent node, then find the in-order successor of this node. Then the third thing we're going to do is set the parent right or left. We have to determine that, right or left, to the in-order successor of deleted node. So basically we're going to set this to here. And then what we're going to do then is determine the successor of the node. So if you're on the right path, then the right link or the right pointer of this will have to be the right pointer of this. So we're going to have to set the right pointer of the in-order successor to the right pointer of the node that's going to be deleted, so that 8 can now correctly point to 9. So there's a little bit of pointer work that needs to be done, right? So the steps once again are find the parent, determine if it is the node to be deleted is the right or the left, find the in-order successor, right? Set the set the parent node, set the parent to the in-order successor, set parent left or right to in-order successor, and then we are going to have to set the left or right of the in-order successor to the left or right of the successor node of deleted node, of the successor of deleted node, right? So these are, so this is a little bit of work that we have to do in order to maintain the sorted order of the tree, and that's what you will be doing in the assignment. Now I'd just like to go over the template to show you what's been given to you. And here we have the template in which we've got the tree node. The template does not contain the implementation to search because you have done that already. But what you've been given here is you've been given the binary tree. We are not kind of using vectors till assignment 10. So, but this is just here. What we've got is now all we need is a pointer to a tree node. And this is what our tree is going to be like. We've got just a simple default constructor here where the root node gets set to null, count to maintain the number of nodes, inserting, which is given to you, and it's a recursive function. And as you remember, recursive functions have two methods, the one that kicks off the recursion and then that continues the recursion. Now, search is something that you would have written. Some additional methods to search the parent node and then to search the successor nodes. In-order traversal has already been given to you. Remove function just deletes, releases the memory, and check if it has one child, etc. So basically, this is the API for the binary tree data structure. The implementation consists of a simple constructor. This is done for you. The insert function is given to you. A lot of functions, check whether it has one child and so on, have been given to you. The main method that you need to write is the delete method, right? And even in the delete method, some part of the code is given to you. If the tree is empty, exit, right? And then if the node is not found, exit. And then check if it is a leaf, check if it has one child, and then the last case where you check if it has two children. A lot of helper methods are given to you, and search previous, etc. is here. So what does the main program do? The main program constructs a tree with 13 nodes, and it prints the tree, and then we are going to delete some nodes. Some of these nodes are child nodes, some of them are nodes with 1, nodes with 2, and then print the tree after the deletion. So this is what you will be doing, primarily writing the delete method and testing that the delete method works so that your output looks like this. Initially, you have a tree with 13 nodes. You delete some of these nodes and the in-order traversal should look like this.